humanity's most advanced eye in the cosmos, the James Webb Space Telescope, has just uncovered a jaw-dropping cosmic event, one that's sending shockwaves of wonder through scientists across the globe. Far past the warm embrace of Earth, beyond Mars and Jupiter, something enormous just crashed into the distant icy world of Neptune. For the first time in human history, a space telescope has captured the aftermath of a massive collision on one of our solar system's farthest giants. But this discovery isn't just about Neptune. It's a wake-up call that even in the frozen corners of our solar system, violent and unpredictable events are still shaping the planets. Before we dive deeper, tap that like button and subscribe to stay in the loop with the latest from the universe. It all began with a strange glitch. While Webb was busy monitoring Neptune's atmospheric patterns, part of its mission to study seasonal shifts on the ice giant, something unexpected showed up. Glowing hotspots appeared where there should have been nothing but calm, swirling methane clouds. The patterns looked chaotic, almost like scars across the planet's surface. Using its powerful infrared sensors, Webb picked up intense heat signatures in a localized region of Neptune's atmosphere. This wasn't a minor blip. Something big had happened. The thermal burst was too massive to ignore, pointing to one possible cause: an enormous impact. With all the data in hand, astronomers pieced together the most likely story. A colossal object, maybe a drifting asteroid or a wayward mini-planet, had slammed directly into Neptune. Judging by the energy released, the object may have been dozens of kilometers wide, hurtling through space at unimaginable speeds. To put it into perspective, the impact would have released more energy than millions of nuclear bombs combined. The explosion tore into Neptune's upper layers, sending shockwaves through its deep blue atmosphere and rattling its weather systems. But this wasn't just a simple crash. It was a celestial chain reaction, one that temporarily exposed layers of Neptune that scientists had never seen before. The disruption pulled material up from the planet's mysterious inner atmosphere, offering a rare glimpse into its hidden chemistry. For the first time, researchers could observe what lies beneath Neptune's typically veiled exterior, and what they saw may change what we know about ice giants forever. But the implications reach even farther. For years, astronomers believed that the outskirts of the solar system were mostly calm, evolving slowly over eons. This impact challenges that belief. It shows that even out near Neptune and Uranus, colossal and chaotic events still unfold, and we've only just begun to catch them in the act. Webb's latest revelation has cracked open a long-standing assumption about the outer solar system, that the Kuiper Belt, that sprawling field of icy relics beyond Neptune, might be far more chaotic and restless than we ever imagined. The idea that massive objects can be knocked loose and flung inward at blistering speeds raises fresh concerns about planetary safety and challenges how we understand the solar system's evolution. It's like discovering that a quiet, distant neighborhood is actually a cosmic shooting gallery. What hit Neptune wasn't just big, it was disturbingly big, and its journey hints at invisible forces stirring in the dark. Could gravitational nudges from a mystery planet, perhaps the elusive Planet 9, or even a rogue star slipping past the solar system's outskirts, be the culprit? If so, then this wasn't just a one-off event. It could mean that every planet, even Earth, is occasionally vulnerable to impacts from deep space, though they may happen across millennia. And it wasn't just Neptune's surface that felt the blow. Its magnetic field, already one of the strangest in the solar system, tilted wildly and offset from the planet's core, might have been briefly shaken by the collision. Instruments picked up odd disturbances in the magnetic environment just after the impact, offering a rare chance to study how planetary fields respond to sudden external forces. That's huge for exoplanet studies too, especially when considering what makes a planet habitable. But perhaps most eye-opening of all, this impact has prompted a total rethink of how ice giants evolve. If collisions like this have happened before, even if millions of years apart, they could be responsible for shaping the chemistry, heat flow, and rotation of planets like Neptune and Uranus. Those atmospheric streaks and magnetic quirks we once chalked up to slow internal processes might actually be battle scars from ancient space encounters. Thanks to Webb's unparalleled sensitivity, this wasn't just a blurry glimpse, it was a front-row seat to a cosmic event as it unfolded. Unlike previous telescopes, which might have missed it altogether, Webb caught thermal spikes, chemical changes, and shifting debris clouds, all in real time. This marks a leap in how we observe, understand, and respond to cosmic phenomena. But there's a sobering side too. Neptune's collision reminds us just how unpredictable space can be. Despite all our advancements, the universe still runs on chaos. Random, violent, beautiful chaos. Earth's calm skies might not be permanent, they're just part of a temporary balance. This moment underscores why it's so vital to continue studying space threats and developing long-term planetary defense strategies. On a deeper level, events like this one reveal something far more profound. Planets, stars, and systems aren't frozen in time. They're evolving, reacting, and sometimes being reshaped in an instant. The cosmos isn't a finished painting, it's a living, breathing story where even giant planets can be rewritten by fate in a heartbeat. Thanks to Webb, we're entering a new era of discovery. Scientists are now racing to simulate the impact, trace the object's origin, and study how Neptune may have been altered from the inside out. Early computer models suggest that the impactor may have shattered on entry, sending high-speed fragments into the planet's core, possibly changing its structure in subtle but lasting ways. Every layer of Neptune, from its swirling clouds to its magnetic heartbeat, may now carry the imprint of this extraordinary encounter. And for astronomers, it's just the beginning of unraveling a story written in light, gravity, and time, one collision at a time. From an observational standpoint, the massive debris cloud launched by the impact gave scientists a rare window into Neptune's atmosphere under intense pressure and chaos. As the shockwave rippled outward, it uncovered intricate patterns of atmospheric behavior, refining our understanding of how gases move and react under Neptune's icy high-pressure conditions. This isn't just helpful for decoding Neptune, it's also a major step toward interpreting the atmospheres of distant exoplanets that might resemble this remote blue giant. One especially intriguing idea sparked by the event is tied to a long-standing mystery: Neptune's unexplained internal heat. For years, researchers have puzzled over why the planet radiates far more heat than it absorbs from the sun. This sudden impact may provide a clue. Could it be that occasional high-energy collisions inject bursts of heat, disrupting the cooling process and recharging Neptune's inner engine? If that's true, then these moments of violent upheaval could be critical in sustaining the planet's warmth, like cosmic jolts, restarting its internal pulse. For planetary scientists, witnessing this in real time is nothing short of a jackpot. It's one thing to theorize how impacts might shape a planet, it's another to see it unfold with live data. The ripple effects stretch across disciplines, from how solar systems form, to how alien atmospheres work, to how Earth might prepare for the distant but real threat of incoming space objects. This single event becomes a cosmic metaphor. It shows how destruction and creation go hand in hand, how the universe evolves not through stillness, but through motion, disruption, and transformation. The James Webb Space Telescope has already redefined our view of the cosmos, but in catching this collision, it's done something deeper. It's captured the solar system's pulse, its wild, unpredictable life force in real time. As more data streams in, every piece adds to a vivid portrait of Neptune, not a calm, sleepy planet, but a dynamic world shaped by fire and force. The planet's story is no gentle painting. It's a canvas splashed with the drama of impact and upheaval, shaped not by slow erosion, but by sudden bursts of cosmic fury. And that's the real message. The universe isn't a quiet museum of static orbs. It's alive, it breathes, it changes. Neptune's impact is a fresh chapter in a much older tale, a tale of origins and endings, of fragile balance and violent shifts. The collision Webb captured isn't just a moment frozen in time. It's part of a living chronicle that stretches from the solar system's fiery birth to its unpredictable future. Even Neptune's surrounding moons and rings weren't left untouched. As high-resolution images poured in, researchers noticed something surprising. The collision may have subtly disturbed the orbits of Neptune's inner moons. Tiny satellites like Naiad and Thalassa, already locked in tight, delicate gravitational dances, might have shifted ever so slightly. A small change in velocity or distance today could trigger gradual but significant changes over decades or centuries, possibly reshaping the layout of Neptune's entire moon system. What began as a sudden flash of violence may now echo through time, gently rewriting the orbits, energies, and identities of Neptune's companions. It's a quiet but powerful reminder. Nothing in the cosmos is truly still. Some new simulations suggest the collision may have set off a chain reaction with Neptune's smallest moons. Gravitational tremors from the impact could, over time, destabilize tiny moonlets, possibly sending them crashing into the planet or flinging them into deep space as cosmic runaways. If proven, this would rewrite what we thought we knew about the long-term evolution of moon systems. It would mean that one major strike could permanently reshape a planet's lunar family, not just around Neptune, but possibly around Jupiter, Saturn, and beyond. Another unexpected revelation came from Neptune's ghost-like rings. Unlike Saturn's dazzling halos, Neptune's rings are thin, dark, and clumpy, easily overlooked until now. But following the impact, Webb observed subtle disturbances sweeping through several of the ring arcs like ripples on a pond. These vibrations may allow scientists to better understand the physical makeup of Neptune's rings, their weight, their density, even their age. And that leads to a big idea. Planetary rings might be more delicate and short-lived than once assumed, vulnerable to sudden jolts that can reconfigure them in an instant. Then came another surprise: chemical fingerprints left behind by the impact. Webb detected brand new molecules in Neptune's atmosphere, including complex hydrocarbons never seen there in significant amounts before. These likely formed in the intense heat and pressure of the shockwave. While Neptune is far too cold and harsh for life, the appearance of these organic building blocks draws fascinating comparisons to early Earth. It shows that cosmic collisions, even in hostile places, can spark chemistry that, under the right conditions, might someday lead to biology. Even Neptune's auroras got a dramatic upgrade. Normally, these soft polar glows are caused by solar wind particles interacting with the planet's magnetic field. But this time, the impact itself supercharged the auroras, unleashing dazzling energy around the poles. The event offered scientists a unique chance to see how a planetary magnetic field responds to direct trauma. And this kind of insight could prove essential in decoding strange auroral patterns on faraway exoplanets. One of the most compelling observations came from Webb's infrared sensors. After the impact, they spotted sharp temperature spikes in specific regions on Neptune. These warm zones spread out in unpredictable asymmetric patterns, revealing hidden dynamics within the planet's atmosphere, like unseen jet streams, vortexes, and deep convection tunnels. These were long theorized features, but now, for the first time, we have direct evidence. This discovery could finally close long-standing gaps in our understanding of how heat moves inside gas giants, an unanswered question since Voyager's visit decades ago. Meanwhile, theorists began tracing the journey of the object that hit Neptune. Some believe it didn't just come from the nearby Kuiper belt, but from even farther out, beyond the solar system's icy frontier. That idea alone is thrilling. It means our solar system is still connected to the larger cosmic web, and that forces, be it from rogue stars, drifting dwarf planets, or ancient leftovers from the solar system's birth, could shift the trajectory of distant objects in ways we're only beginning to understand. What this all adds up to is clear. The solar system isn't a closed chapter. It's a living, evolving system filled with surprises, where even the outermost planets can be shaken by invisible hands and rewritten in moments. Neptune's collision, as caught by Webb, isn't just an event, it's a revelation. Neptune's dramatic impact is now being hailed as a cosmic chain reaction, triggered by a subtle gravitational nudge and ending with a colossal strike visible across billions of miles. What started as a small ripple somewhere in the outskirts of the solar system ended in a massive planetary collision, reshaping how we understand the domino effect of space dynamics. One of the most mesmerizing insights from the James Webb Space Telescope was the strange glow left behind after the collision. The light reflecting off the debris wasn't just bright, it was different. Webb's spectral analysis revealed materials that may be completely unfamiliar on Earth, including rare ices and rocks, possibly unchanged since the solar system's infancy. These frozen time capsules could hold clues about the raw ingredients that shaped our sun, our planets, and everything in between, without needing a spacecraft to scoop them up. The collision also opened new questions about Neptune's inner makeup. Traditionally imagined as a small rocky core wrapped in thick layers of ice and gas, Neptune's true internal structure is still mostly unknown. But now, scientists are using the way the planet absorbed the impact to better understand its density and layering. If the shock waves traveled in unexpected ways, it could challenge long-held beliefs about what lies beneath Neptune's clouds. This cosmic event has reignited interest in sending missions to the ice giants. Unlike Mars or Jupiter, Neptune and Uranus have barely been explored. Some researchers now argue for a dedicated orbiter mission to Neptune, one that could even carry seismic instruments to detect quakes and tremors caused by impacts. Such a mission might unravel not just Neptune's secrets, but offer a deeper understanding of how planets are born around stars across the galaxy. Astronomers are also keeping their eyes peeled for a possible ripple effect. There's speculation that the collision may have shifted Neptune's gravitational influence just enough to tug on nearby space rocks, possibly nudging a few icy comets toward the inner solar system. If true, we could see a rise in comet activity here on Earth over the coming decades, a beautiful but sobering reminder of how one event in deep space can echo across the entire solar system. On a larger scale, Neptune's collision forces us to rethink the risk of cosmic impacts. If such powerful collisions are still happening among the gas giants, who's to say the inner planets, like Earth, are immune? These events might be rare on human timescales, but in the grand timeline of the universe, they're inevitable. What's more, the impact created detectable bursts of electromagnetic energy, a discovery that could help astronomers identify similar impacts in distant solar systems using just radio waves and telescopes. But beyond science, the event sparked deeper questions about life, fragility, and our place in the universe. Planets aren't permanent. They evolve, they suffer damage, they can change without warning. That realization brings new appreciation for Earth's relative calm and adds urgency to the conversation about planetary protection. The night sky may look still, but it's filled with motion, mystery, and sometimes danger. Some theorists are now floating an even more mind-bending possibility. What if the object that struck Neptune wasn't from our solar system at all? There's a chance it was a rogue fragment, an interstellar traveler caught by the sun's gravity. If that's true, this would be the first recorded instance of an object from another star system colliding with one of our planets. That would completely redefine how we view interactions between solar systems and the wider galaxy. From a technology perspective, the event is a huge win. James Webb's detection of such a fleeting, unplanned cosmic event shows just how far our tools have come. It proves that adaptable, all-sky observation strategies are essential. Sometimes it's not the expected discoveries that change the game, but the surprises we're ready for. If you enjoyed this video, give it a like, subscribe to our channel, and leave your thoughts in the comments. Do you think this was an interstellar visitor? What do you believe Webb uncovered on Neptune? We'd love to hear your take. Thanks for watching, and until next time, keep your eyes on the stars.